So boys, we're going through another few examples here. So this next one, we're finding the points of intersection, remember, for y equals 6x minus 6x minus 3, and y equals x squared minus 8x plus 46. So put the two equations down with equal signs underneath each other. One's equation 1 and the other one's equation 2. Because they're both equal to y, we're going to make them equal each other. So you can put them as 6x minus 3 equals x squared minus 8x plus 46, or the other way around, whichever you want. So I've written it this way. So we're going to make everything go to the left-hand side and keep our 0 on the right, because we can see we're dealing with a quadratic equation. We have to have that 0 on one side. So keep your x squared, keep your minus 8x. Move the 6x over to be minus 6x. Keep your plus 46. Move the minus 3 over to be plus 3. Collect your x's and your numbers, and we have x squared minus 14x plus 49 equals 0. Factorising, we have a product of positive 49 and a sum of minus 14. Factor pairs for 49 are here. Obviously, it's going to be the 7 and the 7 to get 14. The highest gets the minus. Well, 7 and 7, take your pick, give one of them the minus. The other one has to be the same, so that's a minus as well. So now we have x minus 7, x minus 7 equals 0. So your bracket is the same. So there's no point writing down x minus 7 equals 0, x minus 7 equals 0, because we're going to get the same result from both of those brackets because they're identical. So we're only going to get one x coordinate, and that is x equals 7. So we have one point of intersection for this. So we have one x value, and now we're going to find its y coordinate to go with it. So we're going to sub the x equals 7 into that equation, because equation 1 is a lot easier than number 2. You can pick either, but that one's much easier. So we're going to go into y equals 6x minus 3. Put your 7 in for x. Work it out and you have y equals 39. So our point of intersection, only one point of intersection this time, is 7 and 39. So if we draw this graph up, just to quickly see what it looks like, we have a concave up parabola because it's y equals positive x squared here in the parabola. The line is y equals 6x minus 3. It has a positive gradient, so we know it's going to lean that way. And we know it's only got one point of intersection. So when you try and think, well, where am I going to put this line so that it only cuts the parabola once? Well, it would have to be somewhere over this half of the parabola. It couldn't be over there because the line would have a negative gradient. It couldn't be on the bottom here because the gradient would be 0 for a horizontal line at the bottom. So it's somewhere on this half of the parabola. So anywhere you like, draw a straight line. And 739 is the point of intersection. So really, what's going on here is that that line is a tangent to the parabola. Any straight line that touches a curve, any curve at one point, is a tangent to it. So when you're riding your bike and you look at your bike wheel and you look at the road, your bike wheel, the circle, and the road have one point of intersection at any one time. It's where it connects with the road. Okay? So the road is a tangent to the wheel on your bike. Okay, so we're going to look at another question here. This one we have x plus y equals 3. That's a straight line. It just is written the way they want to write it. And we have a circle this time. We haven't done circles yet, but we will be doing them this year. So the circle is x squared plus y squared equals 9. So we're going to put the two equations down. Doesn't matter what they give you. Just put the two equations down, equation 1 and equation 2, and go and find the points of intersection. So in number 1, this is not as easy as this question where we just make them equal to each other because they were both equal to y. This one we have to fiddle around a bit. The two methods you have for simultaneous equations are substitution and elimination. Elimination will never work when you have powers, okay, because you've got to have the x term with the same number in front of the x or the y term with the same number in front of the y. It doesn't allow for x squareds or x cubes or anything else. So once you see you've got powers, it has to be the substitution method. Right, so as soon as you see powers, we're thinking substitution method. Okay, so we're going to look at the easy equation, the one up the top here, and we're going to make one of those letters the subject of the equation. I've picked y, but you could have picked x, it didn't matter. So I'm going to get y isolated. I'm going to move the x to the other side, so it's now going to be 3 minus x. Remember, when we did the substitution method, we called that the asterisk equation because it was an easy one to come back to later. Now we're going to sub the y equals 3 minus x that we've just got into the other equation, into number 2. So we're going to write equation 2 down, x squared plus y squared equals 9. And where you see y, you're going to write 3 minus x. But because there's more than one term, make sure you have those brackets there. Okay, so we've got x squared plus bracket 3 minus x bracket squared equals 9. So we're just going to solve this and find x. So the first thing we're going to do is expand this bracket. But I want you to do this the way you're going to have to do it in year 11 and 12, which is by doing what we've been doing with the squares. Square the first term, twice the product of the two terms, and square the last term. So let's see how we go. We'll copy down this x squared first. Here we square the first term, and that gives you 3 squared is 9. Then we're going to get the product of these two terms is minus 3x. Double it, just double the number part, and you get minus 6x. And then square the last term. So when you square minus x, it's plus x squared. And then copy your equals 9. So we're going to collect our x squareds over here. 1x squared plus 1x squared is 2x squared. Minus 6x plus 9, and we've still got the equals 9 over here. So this is quadratic now. We've got a quadratic equation with that x squared there. So we're going to take everything to one side and make it equal to 0. So just move over that 9 to be minus 9. And collect yours plus 9 minus 9 gives you nothing. So there's nothing there. So it's just 2x squared minus 6x equals 0. Now when you get to there, don't ruin it by using the wrong method of factorising. You know that when you're looking at factorising methods, the first one you should always try is the common factor method. This has two terms, and there is a common factor of 2x. We're going to take that out, and inside the bracket we're left with x and minus 3. Close the bracket equals 0. So don't forget, this is like its own little bracket here. So we're going to take each bracket and make it equal to 0 and solve each one. So sometimes people do all sorts of weird things with this 2x here. So I'd rather you just make sure of what you're doing before you write something silly down like x equals 1 or x equals 2. You're taking 2x and making it equal to 0. So we want the x by itself, get rid of the times 2. Come over here, divide by 2, or use it as a bracket, as a fraction in your fraction key. 0 over 2 equals 0. Right, so there's no doubt that answer is going to be x equals 0. This one here, when you make it equal to 0, will give you x equals 3. So we're going to sub x equals 0 and 3 into the asterisk equation because that's the easiest one. I don't want to go into 1 or 2. I'm just being interrupted by the class next door. Okay, so we could go into either one of those, but that's the easiest one. Thank you, Mr. O'Shea.
Yeah,
I'm videoing. Do you want to be on the video? Okay, so we're going to go into that one because that's the easiest.
Yeah, it looks pretty easy to me.
Guest appearance. You'll be famous one day, you know.
One day.
One day. Keep trying.
I will.
Okay, so back to what we were doing. So we're going to take x equals 0 and x equals 3 and put it into the asterisk equation, one at a time. So take the x equals 0, it goes into y equals 3 minus x. Put the 0 in for x and work that out. You get y equals 3. When we take the other one, x equals 3, and put it in there, you get y equals 0. So we end up with 2 points of intersection. One is 0, 3. The other one is 3, 0. And if we draw what's happening, we have a circle for x squared plus y squared equals 9. They told you it was a circle. And a straight line. Now, if we investigate what the straight line looked like, in the asterisk equation, it has a negative gradient. So it'll lean that way. So this straight line is cutting through the circle at 2 points. This one would be the 0, 3. And this one would be further along because the x-coordinate's further that way. So that's 3, 0. Okay, the last one we're doing is y equals 5x plus 2 and the hyperbola y equals 7 over x. We're going to be doing hyperbolas later in the year. Alright, so put the two equations down one above the other, equation 1 and equation 2. In this one, because they're both equal to y, you can make them equal to each other. Now when you're looking at that, it looks a bit messy. All you've got to do is remember to get rid of this. We want to get rid of that. So the only way you're going to get rid of it, because it's being divided by x at the moment, is to multiply by it. So you have to do it to every term. So every one of these 3 terms, we're going to multiply by x. So this one becomes 5x squared, this one becomes plus 2x, and over here, they cancel. Remember when you're writing the 7 over x to make sure the 7 is written in line with the top of everything else, and this x drops below it. Make sure it is written below. So they cancel, you get a 7 over there. So all fractions are gone now. You can see it's quadratic, so make it equal to 0, move this over. And then we're going to factorise as normal. So product is minus 35, the sum is positive 2. We look at our factor pairs and we have 1 and 35, and 5 and 7. So this is one going to be our pair, get a 2. Highest gets the plus, the difference, and this is a minus. So now we set it up. We've got a 5 in front, remember? So it's 5x, 5x, and 5 on the bottom. Throw in your minus 5 and your plus 7. And now we're looking for a common factor in the first bracket. 5 outside of x minus 1. And the second bracket doesn't have a common factor. Cancel down those 5s, or cancel out the 5s. And you're left with x minus 1 by 5x plus 7 equals 0. Take each bracket and make it equal to 0. And if you follow through the steps, you end up with x equals 1 and x equals minus 7 over 5. So we're going to take those two x values and put it into the easiest equation, which would be that one. Oh, maybe you think it's that one. You pick out of those whichever one you think is easiest. I thought this one would be better, so I'm going into that one. So we take x equals 1, put it into that equation, and we get y equals 7. Put the x equals minus 7 over 5 into that same equation. Use your calculator, and you'll get y equals minus 5. So your points of intersection are 1, 7, and minus 7 over 5 minus 5. So if you drew it, now I know you don't know what hyperbolas look like, but I'm just going to show you now. The black drawing is the hyperbola. There are 2 parts to it, 2 parts to the graph. And we have dotted lines here which are called asymptotes, which we'll be learning later, where we have a little break in the graph. That's why it's not all smooth one graph. Okay, the other thing is this line here with a positive gradient. So it's going to lean that way, and we know it cuts through at 2 points. This would have been the point 1, 7, and this one down here would have been the point negative 7 over 5, negative 5. So I hope you understand that. Do your homework, and this is the last lesson that we have before we're back to face-to-face teaching, thank God. So we've just finished this topic. This topic itself won't be in the exam. There will be simultaneous equations and coordinate geometry are the 2 topics in your exam. And when we get back to face-to-face teaching, I'm going to be asking if there's any issues or any problems you want me to work through. So if you go through anything that we've been doing and there's a question that you've got about something you couldn't do or you got wrong, just write everything down on a piece of paper for me, what exercise, what question, and I'll work through them with you over the next week or so. Okay? So good luck with your homework. See you soon.